Okay, so welcome to this video on factor by grouping. Factor by grouping, as you see in red there, is used if you have 4 or more terms. There are 3 basic steps to factor by grouping. You want to take your expression and break it up into 2 parts. So right there. And then you want to factor a GCF from each part. So I look at this and I look over here and I see a x and an x to the 1 there. So the greatest least variable power they have in common is x1, and that leaves me with x plus 2. And now I'm looking at 6 and 12, so I can see the 6 is 6 times 1 and 12 can be thought of as 6 times 2. So in terms of numbers, 6 to the first is the least power, and then I have x plus 2 remaining. Now when you do factor by grouping, do not forget this sign in the middle. It is important to write that. Now that's the second step. Now the third step says factor a GCF again, and if you stare at this long enough and if you've done this right, you will have a GCF right there. So you factor out the GCF again, that's going to be x plus 2, x plus 6, the remainder. And that's it. That's your answer to a factor by grouping, that 4-term expression. So let's take a look at another problem. And this one here would be 30x to the second plus 18x plus 35x plus 21. Strangely, getting the numbers right actually is harder than the letters. You can, immediately look at this and say, well, x is in the GCF from the first two right there. But the numbers might take a little bit more work. So let's see if I can break the numbers up. So I can think of 30 as 6 times 5. And I can think of 18 as 6 times 3. And so the number they have in common with the least power is 6 to the first, because 3 and 5 don't have anything in common. So the GCF is going to be 6 to the first, and in terms of variables, it's x to the 1, and then what's left is a 5 and an x plus a 3. And over here, we can sort of do the same thing. Let's see here. 35 I can think of 7 times 5. In this I can think of as 7 times 3. And so the greatest thing they have in common number-wise is 7 to the first. So I can take out a 7. That leaves me with a 5x plus 3. And don't forget the sign in the middle. And so that's our first step is to divide, second step is to factor GCF once, and the third step is to factor GCF twice. So here's my GCF a second time, and so I take that out, 5x plus 3, 6x plus 7, and I am done. Example, factor. Alright, so the thing about 4-term expressions is you can make it easy on yourself if you start to notice a certain pattern. And the certain pattern that you notice is that this here has to be exactly the same as that right there in order for you to have a GCF. So you can sort of take advantage of that. So let me show you what I mean. So let's say that I had this to factor. 12x squared minus 4x minus 3x plus 1. And so I look at this and do this. So this is the first step. I divide the problem into 2, and so in the second step I'm looking for GCF. So especially I'm looking for GCF in the first part. So I can think of this 12 as 4 times 3, and so I see a 4 common, and I can also see a x common. So my GCF is going to be 4x, and my left behind is 3x minus, in this case, so the 4 and the x are all gone, so all that I have left here is a 1, so minus 1. Now if I remember my trick from above, that I know that I must get another 3x minus 1 here, that's helpful. I have half the answer for the second half of my problem. I have half the answer. And now it becomes a simple question of what number do I have to put here in order for this to work out to be that, right? So if you stare at that long enough, you see that it has to be minus 1, because minus 1 times 3 gives you minus 3, and minus 1 times minus 1 gives you plus 1. So you can use this first answer right there in order to help you, because you know those two have got to be the same. So now you can do the third step of your GCF, which is to say 3x minus 1 and 4x minus 1, and that's your answer. Let's do another one. Factor, and this time let's say that we had 5x squared minus 15x minus 2x plus 6. So again, I divide the problem, and I'm only going to look at this part right there. And so 5 is 5 times 1, 15 is, we can think of this as 5 and 3, 5 times 3. So we know that 5 is common there, 5 is common here, and x to the first is there, and x is here, right? So the GCF is going to be 5x. And so in the first place, we have an x minus 3 in the second place. Now, without even looking at that second part of the problem, I know that I must get x minus 3 there. It must happen. So, simple question. What do I have to put here in order to get plus 6? Right? So it has got to be a minus 2. Minus 2 times minus 3 gives me plus 6. Now, must also work out for this 2x. Minus 2 times x is minus 2x. So it works out in that quadrant as well. So remember, this is step 1 where you divide everything into 2. This is step 2 where you do the first GCF, and now your x minus 3, which you very carefully reuse there, is your second GCF. And you're done. Now, one thing to remember when you're doing all these problems is that an overall GCF, if there is one, that always has to be done first, right? So there's a couple of ways in which you can approach this. So let me show you the two ways, and I'll leave it up to you to decide. But when somebody says factor, it means to factor fully. So example, factor, which really means factor completely. Right? So let's take a look at this problem. 5x cubed minus 10x squared plus 15x minus 30. So let's do, it's a 4-term expression. Let's do this like we would normal 4-term expression. So I'm going to divide this 10 up. I'm going to write the 10 as 5 times 2, and then immediately I see there's a 5 and a 5 to the first, and then an x to the second right there, which is common. So my GCF for the first two is going to be 5x to the second, which leaves me with an x in the first place minus a 2 in the second place. Now I know that I must get x minus 2 over here, so there it is. So then the question is, what do I put in between them? What number do I have in between them in order to get this to work out? So that's a 2, negative 2, and that's a negative 30. So this has better be a positive 15. Positive 15 times negative 2 is negative 30. Now, does it work out for that as well? Yes, it does. So step 1, divide. Step 2, GCF. Step 3, GCF. So here is my second GCF. So step 3, x minus 2, 5x squared plus 15. Now if you're sitting there thinking, whoa, the problem is done, unfortunately it's not. If you look carefully at this part right there, that has a GCF, right? 15 is 5 times 3. And so you can notice that there is a 5 common to both. Now if you stop the problem right here, what you have failed to do is factor completely. You have factored, but not factored completely. So what you need to do is take out that 5 as well. So you could do x minus 2, 5, x squared plus 3, and now you have factored completely. You can rearrange these terms and write it like so. And this is something that you really must remember to do always, to factor completely. So if you can factor some more, you must factor some more. Now this problem, so this is one way to do that problem. There's another way to do that problem, and that is to look for GCF right up front, overall GCF right up front. And so let me do that problem over here, side by side. So over here I look for an overall GCF, and I notice that this is 5 times 2, this is 5 times 3, that is 5 times 6. So there is a 5 all the way through, and so I can take that 5 out, and I'm left with x cubed minus 2x squared plus 3x minus 6. And now I can factor inside the parentheses. So there's the 5, and I can now divide this into 2. And so between these two there is an x, certainly, and the least power is that. So x squared is my GCF, leaving an x minus 2 in that spot. And I know that this has got to be an x minus 2 as well. So this is like step 1 of my factor by grouping, and then this will be step 2 of my factor by grouping after I've done the GCF over here on the side. And so that's a negative 2, that's a negative 6, so this has to be a positive 3. Check, 3 times x is also 3x, so that checks out. And then this is step 3 of my GCF. So I have my 5, I have my x minus 2, and I have my x squared plus 3. And so there it is. There is the answer. So there's two ways to do the problem. It doesn't matter which way you do it, but it is important that you factor completely, right? So remember, you could have an overall GCF. So check for it either at the beginning or at the end. Doing it at the beginning, the advantage is your numbers become smaller. Doing it at the end, some people find doing it at the end much easier, but that's a personal preference.